So I'm writing integration can be used for finding area, arc length, and volume of rotation. So this is one sentence you can say. There may be other things, but we are not talking about everything. So how integration is applicable or useful? So this is its answer. Now we need to know, we need to understand what is actually the value after definite integral. So let me take one example, then it will be clear. Say a very simple example, integration, then 1, and then 4, and I'm writing very simple example first. Oh, let me use my board. Mouse is not really comfortable. So this is one simple example. I'm writing a function here. It is 2x and then say plus 3 and then close bracket dx. So this is the question. So everyone knows how to do this problem, and you can easily understand how the results are coming. So I'm just doing it quickly. So integration 2x, it will be 2 into x square by 3, and then plus 3 into x. So close the bracket, it is third bracket, and then 1, then 4. So now 2 cancel. So you can have the result as x square plus 3x. So you put 4, so it will be 4 square plus 3 into 4. I'm putting 4 in the whole result, and then minus I'm putting 1 in the whole other. So 1 square plus 3 into 1. So it is 16, 12. So 28 minus 4. So it is 24. So this result is 24. It is very, very easy. Everyone understands. Now my point is, if I want to clearly understand what is this 24, then I will go to the x-axis, y-axis method. So you already know the x-axis and y-axis, and you can easily draw a graph. I mean, at least some of you, okay, may not be everyone, but some of you. So in this integration problem, the function is 2x plus 3. So this is your function. So if you think that y equal to 2x plus 3, this is my function, and if you draw this graph, what will be the shape of the graph? Can anyone tell me what will be the shape of the graph for this one?
Linear.
Do you know the shape of this graph?
It's a linear.
Linear, yes. This will be a straight line. It is correct. So if you know how to draw the graph, then fine, you can draw it. So there are different ways actually. Okay. If you know this is the equation of a straight line, then fine. If you just put the x value, y value like any number 0, then y will be 3. So it is 1, so y will be 5. it is -1, so y will be 1, something like this. So in this way, there will be 1, 2, 3, 4 here, right? 1, 2, 3, 4, and -1, -2 on the x-axis, and there will be 1, 2, 3, 4 on y-axis also. So in this way, you can just give the numbers on scale on the x-axis, y-axis, and then finally you can get the line. This is a straight line, and it will be -1, 1. Okay, so it will be like this. It will be like this. So if you understand, if you know already what will be the shape of the graph, then fine. If you do not know or do not understand, that is also okay for this course, because in this course actually we are not going into that deep. So what I want to tell you, this is the graph of y equal to 2x plus 3. So the function we have integrated here, we will consider that as our function, and then we draw the graph. So this is the graph, and the x value given as a range from 1 to 4. So you can find out the range of values here. So it is like x will be 1, this is the lower boundary, and x will be 3, this is the upper boundary. So it is on the x-axis. So let me just draw two vertical lines. One will be going over the point x equal to 1. So say this is it is x equal to 1 line. Another is x equals to 3, so it is this x equal to 3 line. Is that okay? Do you understand my drawing?
Sir, it translates the function of 3 units, right?
What 3 unit? I could not understand your
Sir,
point.
the 2x plus 3 plus 3, it is up 3 units, right?
Yes, this is up 3 units, because the first point is in this table. The first point is 0, 3. First point is 0, 3. So x is 0, y is 3. So this is the point actually. X is 0, y is 3. This is the point. Okay. So I can understand how the straight line will go, how the straight line will be drawn here on the graph. So if you can do it yourself, that is also fine, no problem. So now I have drawn two vertical lines. One is the left side boundary, one is the right side boundary, and those two vertical lines are coming from the given range of x values. So you have got one specific place. What is the place? The place is surrounded by 4 lines. One is the graph itself, that is the blue line. One is the x-axis, that is the x-axis line, red color line. One is the left side boundary, that's the lower boundary of x value, and right side boundary, that is the upper value of x value. So you have got one particular place, and if you just make a color here, okay, so this is the color yellow. That yellow place, the area of this particular place is actually 24. What we have got as our answer, this particular area is 24 square unit. So,
Sir, isn't the range 1 to 4, sir?
oh, this is 4. Yeah, it is. You are right. So let me make the changes here. Yes, you were right. So it is actually not 3, it is actually 4. So let me just shift the right side line a little. Okay, so it will be this line. It is 4. You are right. Okay, so নাবিদ ছাড়া তো আমার চলতেছেই না দেখা যাচ্ছে, কেউ কিছু বলে নাই। Okay, so this is correct. It should be 1, 2, 4. So we are now getting the thing like this. Okay, is that okay now? The left side boundary is 1 and right side boundary is 4 because it is given in the question. 1, 2, 4. So this area, the yellow area, will be 24 square unit. Why it is 24? Because we have got the answer 24. This is the answer. So what does that mean? Square unit, it may be square centimeter if these are centimeter. If you say it is 1 centimeter, 2 centimeter, 3 centimeter, 4 centimeter, like that, all are centimeter, then it will be square centimeter. If everything is inches, then it will be square inch. If everything is foot, then it will be square foot, like that. So this is the understanding. Now let me just summarize the idea. What is the definite integral result? Actually, the definite integral result is the area. So the question will come, area of what? Area of what? What area? Then you will say this is actually the area of a certain place which is enclosed by 4 lines. What are the 4 things? One is the graph of the function. Second is the x-axis. Third is the lower boundary line of the x value given. And fourth, right side boundary is the upper boundary line of x value given. So with all these 4 lines, when you get the certain space or place, area of that particular place will come. So let me write it down here. The meaning of area. Which area? Area is of the certain space enclosed by the graph of the function, comma, let me just make it little smaller so that it will be understood. Okay, and then graph of the function, and then x-axis, and then lower boundary line and upper boundary line. So this is actually the understanding of area. So if I ask you which area, then you will explain it this way. So this is the understanding of definite integral, and that is the meaning of area. Which area actually? Is that okay? Do you have the idea now?
Yes, sir.
So
Yes,
do we
sir.
have to draw the graph?
Yes, so that is another big question. Actually, in the exam, you do not need to draw the graph. Okay. So this is for your understanding. Maybe I will give you the graph. That is the drawing. So if I give you the drawing, then you will interpret what I want, then you will do the calculation. But on the other way, I will not give you the question and I will not ask you to draw the graph. So
Okay, sir.
there is two different points. One is some of you are not very comfortable about drawing the graphs because they are not from science background. This is one reason. Another reason is drawing the graph will take a longer time to answer. So that will be a problem for answering on time. So these two reasons should be considered. Maybe I will give you the graph in the question so that you can interpret what I mean. Say for this example, I am giving you the question as a graph, just like this. The equation of the straight line is given here, and 1 is given here, 4 is given here, x-axis, y-axis. And now I am asking, okay, find the area. So I am asking, what is this area? Okay, then you will understand, oh, okay, this area is possible to use integration here. So you will write this thing and then do the calculation and get the answer as 24. So you will say, okay, the area of the shaded region in the question is 24 square unit. So that is your answer. You got my point?
Yes, sir.
Yes, sir.
Okay. So there are two other things. One is arc length, one is volume of rotation. So let me just go to another page in my PowerPoint slide so that you can copy the formula for arc length and also for volume, and then I will come back again. Okay, so I'm going to the PowerPoint slide for the formula so that you can copy the formula first, and I will come back here again. So can you see my PowerPoint slide now?
Yes, sir.
No, sir.
So,
Yes, sir,
so
I can see.
you okay, so you see three formula here.
Yes, sir.
Okay, then copy the formula, and I will go back to the writing screen and show some more problems. Okay, just copy it.
Sir,
Yes,
for the second formula, a to
yes,
b to the power of 1 plus y1 square. What does it
yes.
mean by y1 square?
Y1 is the first derivative. Y1 is the first derivative.
Like we have to do differentiation first.
Yes.
Okay, sir.
So you have copied the formula already?
Yes, sir.
Yes, sir.
Everyone is okay?
Yes, sir.
Yes, sir.
Okay. So let me stop sharing this screen and then go back to our writing screen again. Okay. So the example we were working with, let us find out the area for, area is already done, arc length for this example. Then I will show you another example. Okay. So For arc length of this example is like, let me just erase the left part and do the problem here. So you will apply the arc length formula now. And for the arc length formula, as Azharuddin was asking, you need to do the differentiation, because there is one thing like y1. Okay, so how you will do this? So you will write this like here we have the function y equal to fx as 2x plus 3. So this is the function. Then y1 will be just first derivative, that is ddx of 2x plus 3. So it will be only 2. Okay, differentiation only 2. So now you go for finding the arc length. So you apply the arc length formula. So what is the arc length formula? Arc length formula is integration, then the boundary of x values 1 to 4, and then root over, and then 1 plus y1 square. So what is your y1 here? It is 2.
2 square.
So it is just 2 square, because we have got y1 as 2, and then dx. So it is just number, there is no x here. So it is root over 5, right? It is root over 5. And I can write it directly. It is root over 5. Then after integration, it will be x, root over 5x. And then bracket, then 1, then 4. And it is root over 5 into 4 and minus root over 5 into 1. So it will be 3 root over 5. So 3 root over 5 will be 6.78. No, what? Not okay. 5, 6 or 5, 8, something like this. Find this out.
6.70.
6.7. Okay, good. So I was looking for that. So let me just write it down. 6.70. Okay. So it is 6.70. This is the answer. This is the arc length. Now try to understand what does that actually mean. This is the answer. Correct. Arc length is this. Okay, fine. So what will be unit for this? Is it centimeter or centimeter square? It is not square. This is not an area. It is just centimeter or just inches or just foot. Okay. So what does that mean? That is actually the length. That is actually the length of the line on the graph. That is actually the length of the line on the graph. So which part? It is the length of the line, and this is from this point to that point. This is the line actually. You got my point? You understand? The arc length is the length of the line on the graph, and boundary points will be considered. So that is the range of the line. That is from this point to that point. So what is this point? This means the lower boundary of x value line, and that one is the upper boundary of the x value line, and only the length of the line, that will be called arc length. So arc length here in this case 6.70, maybe inches, maybe centimeter. So that will be the unit. Arc length will be 6.70 unit. Is that clear now?
Yes, sir.
Yes, sir.
Now let me show you another example, and the volume of rotation I will discuss tomorrow, not today. So another example for area and arc length, and the volume I will discuss in the next class. So let me just erase this and do this again. I mean, similar kind of calculation newly for another example. So let me take an example like, say, I'm doing the math first. I'm not, okay, why not? Let us take the graph first. Say the graph is given. Okay. Say the graph is given, and the graph is given for y equal to sin x. So some of you may have idea about sin x graph. This is the sin x graph. Okay. So it will be same in the left side also. So we are not going to the left side. So this is the drawing of sin x graph. Actually the x-axis, y-axis are drawn in red color here, and the blue color graph is for the sin x, and you may already know that the highest height of the graph is 1, and the lowest height, that is the downside, that is also 1, so it is -1. And on the x-axis line, it starts from 0, because you know the origin is 0, 0, and on the right side there are some numbers. So in this case the numbers are the middle point, where the highest point is here. So the middle point is actually pi divided by 2, and the point where the blue line comes to x-axis again, that is pi. So in number, pi by 2 is actually 1.57. Why 1.57? Because the pi value is 3.14. Okay, so pi is a fixed number. This is actually 3.14. So it is a little different, maybe not exactly 1, 2, 3, 4, but it is like 1, 2, 3, 4. There is no problem, because it is 3.14, this point, that means a little more than 3. So this is 3. Maybe the green line is 3. Okay, and then it is little more than that. So it is 1, okay, and it is 2. So like that, 1, 2, 3, 4 will be going on the x-axis line. There is no problem, and in the left side it is -1, -2. But according to the graph, we can say the middle point of the graph, that is the highest point, and just below that highest point is pi by 2, that means 1.57, and that 0 point is again 3.14. So this is the situation. So you do not need to understand all these. If you can, then fine. If you do not know some of the things in trigonometry and graph, that is also fine. Do not worry about that. What I want to say, the graph is about y equal to sin x. This is the graph given here in this example. And I am giving the lower boundary. Say the lower boundary is this. Say the lower boundary is this, and it is actually 0.5. It is 0.5. This is given. So the lower boundary of x is given, it is 0.5. It is given in your question. And the upper boundary is, say it is 3. No problem. Say I am giving you 0.5 to 3. So this is the upper boundary. Okay, I'm giving you the lower boundary as 0.5 and upper boundary as 3. So this is the boundary given. Now I am asking you, say this area is shaded as gray color, and now I am asking to find out the area of this gray region. So I am asking you, okay, find the area. Find the area. What is the area of this region? It is given in your question. So this is the task you will do. And if I also ask you what will be the length of the graph here. So what will be the length of the graph? That is the arc length. So this part is the arc length. Let us do one by one. Let us do the area first. So how you will start? If this is given in your question, you understand, okay, the area is shaded here, and the upper side is the graph, and it is given as y equal to sin x. Lower side is the x-axis, and left side is 0.5 boundary, right side is 3 boundary. Now I will use the integration concept for finding the area. So you will write, okay, we can use definite integral here, okay, for finding the area shaded, okay, in the uh, diagram. So I have just written something so that you can start doing your calculation. So what is the lower boundary, upper boundary? You will just pick up the numbers from the question, from the graph, from the diagram. So you will now directly write, okay, area and the specific area, what is already mentioned in the graph. So this area, and it will be integration, and then lower boundary 0.5, upper boundary is 3.0 or only just 3, okay, and then what was the formula? Formula was y dx. So y is sin x, okay, so you are just putting sin x, that is your y, that's all. This is finished, done. So it is very, very simple. This is integration minus cos x, and then the c is not necessary here. You will put the lower boundary value and upper boundary value, and then put the values here, and of course everything will be in radian. Everything will be in radian. So this is the minus cos 3. One formula minus will come, another minus cos 0.5. All will be radian. So you move to the next, minus cos 3 radian, and then plus cos 0.5 radian. So what is the answer? You can use your calculator and the answer will come. What is the answer comes?
1.8.
All together?
Yes, sir.
Yes, what is that?
So 1.86.
1.83 or 86?
6.
Is this the answer? All together, I mean, combining all the answer.
Yes.
Okay, so this will be the answer. It will be square unit. It will be, you should write it, because the area is square and the length is not square. So this is the area of the question. Is it okay? Everyone understands this?
Yes, sir.
Okay.
Yes, sir.
Okay.
Yes,
So
sir.
good. So if you now want to apply the idea for arc length, what you will do? The graph is given here, and I am now asking about the arc length. So
Sir, all the value given, sir, in the sir picture, sir. Question picture.
yes, in the question, the value of x, lower range, upper range will be given. Otherwise, you cannot really solve this. Maybe this pi by 2, 1.57 is not given. This is not very important for this. Okay, it is for your understanding. Okay? You already should know that this 0 point is 3.14. So if you know 0 point is 3.14, then you understand, okay, the 3 will be little left side. 3 will be little left side of this 3.14 range. So that is the understanding. But if it is not given and you also do not know, then it is not a problem. It's okay. There is nothing wrong. Your understanding is which area will actually come. So this 1.86 is the area of a certain place which is enclosed by 4 things in the foresight, right? So what is the upper side? The upper side is the graph itself. What is the lower side? The x-axis. What is the left? A lower boundary of x. What is the right side? Upper boundary of x. That's all. So if you understand this area, okay, fine, I can do this. So this, you will calculate and get the answer. That's all. Okay. Now let me move to the arc length matter. So let's see what happens over there. So you already know arc length formula. So you need to use differentiation. So you start like this here. Here the function is y equal to fx equal to sin x. This is the function. So it is the graph. It is already given in the question. Now you find out y1. So you find out y1. So this will be ddx of sin x, and you already know what is ddx of sin x. So this will be cos x. And then you apply the arc length formula. So what is the arc length formula? It is integration, then 1 to 4, no, not 1 to 4, it is 0 0.5, 0 0.5 to 3, and then root over 1 plus y1 square. So y1 here cos x. So you will write cos x square, then dx. Then it is actually cos square x, right? So this is a problem you cannot really solve. This is a problem you cannot really solve, because this cos square x within the root over thing we cannot really solve, because we did not learn that technique. Okay, so it is not possible. So what does that mean? That means I will not give you any question which is not possible to solve. So I have to choose the easier questions and which is possible to solve with the knowledge we have discussed in the class. So for this course, it
Sir,
is not possible. Yes.
sir,
Yes.
if we put the sin square minus cos square x equal 1, that formula is in that area, that 1 plus cos square is equal to sin square x,
No, no, no.
and then the square and root.
No, 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 no. You are
We can't
making a
use
mistake. No, no,
trigonometry.
you can, but you are saying something wrong. You can apply any trigonometry formula, any algebra formula, anything. Okay, everything is okay, allowed. But you are saying something wrong. That is sine square x plus. It is not minus. Sine square x plus cos square x equal to 1. You are saying minus, so you are making that mistake. The formula is this. Formula is not minus. You got my point?
Yes, sir. Actually, sir, I
Okay,
forgot.
okay. Yeah,
Mistake.
that is okay. That is pretty all right. So it is plus, so it will go to the right side, so that will be minus. So 1 minus cos square x can be written as sin square x, but it is not minus, so we cannot write sin square x. So anyway, this is possible to solve, but not by the knowledge what we have got here. So somehow maybe it is possible to solve and then find out the answer. So that answer, whatever the answer, 5 or 2 or 3, that will be the length of the arc. You understand my point?
Yes, sir.
And it will be unit, it will not be square, it will be just unit. So maybe centimeter, maybe inches, maybe foot, just only the length. So this is all for today's class. So this is the understanding, and it is all about the application of integration. And integration may be used in many different cases or real life examples. Okay.